what we are going to learn in a networking basics. So first of all, what is a network? Okay, what is network, networking, internetworking? What is LAN, MAN, CAN, WAN, PAN, HAN kind of stuff? Okay, what is intra-network, internet? Okay, what is intranet and internet? Okay, what is a small office, home office kind of stuff? What are the basic requirements required to create a network? So what is NICs? What is a MAC address? What is an IP address? How to check an MAC address and IP address? What is a different type of cables like a coaxial cable, twisted pair cable, UTP and STP cables? What is fiber optical cable? Different devices used in network like a hub, switches, routers, repeaters, modem. Okay. What is our in home? We have a Wi-Fi router, right? What is that Wi-Fi router? About it. Next is a topologies like a bus topology, ring topology, star topology, mesh topology kind of stuff. Okay. And next IP addresses about IPv4, IPv6. In IP addresses, what is the subnet mask, network, and host portions? What is NATPAT? What is private IP addresses? What is OSA model? What are those 7 layers, protocols, and their port numbers? Okay. And then we'll discuss about OSA and TCP IP model, network troubleshooting related. We'll discuss. So today, first we will start with in a basics of networking. What is network? What is networking? What is internetwork? Okay, and then what are the topologies we use in the network? Then we'll see what is LAN, MAN, CAN kind of stuff. Okay. First one is networking basics. So we want PPT link. So it is take more time. So be with this things, guys. Okay, take time means at least 4 days it will take time. The first one is interconnection of 2 or more devices called a network. Interconnection of 2 or more devices called a network. Communication between 2 or more devices is called a networking. And what is internetwork? Internetwork is a connection of 2 or more devices is called a, internetwork is connection of 2 or more networks. 2 or more networks. Internetworking means communication between different networks. So I will draw. The drawing will take time, and that paint-based draw is very easy. And this will take time, but still to understand. See, guys, this is my device. It can be a PC or mobile phone or any just it's a device. You can say normally. So we are in a computer network. So then it is a computer. Okay. So this is my device. For example, it is a A1, A2, sorry, B1. Any name just for our understanding. Okay. So first of all, I made a connection between these devices. It means what I have created a network. Now I created a network. Now, if I can able to communicate from A1 to B1, so A1 send a packet to the B1, it means networking. If I am able to communicate from A1 to B1 or A1 to C1 or B1 to A1, means it is networking. So this is my network, one network it is. I said it is network one. It's a single segment it is. So network and networking. So this is either a switch or a hub device to connect these devices. Okay, I have another network. It's a different network it is. Separate network, separate segment, separate network. Okay, this is also a network. And what is networking? If A2 is communicating to B2 or A2 is communicating to C2, that is networking. It is networking. So I have another networks to separate network. Now, just understand network and networking. What is a network? What is networking? There is two different networks. Maybe in the same area, different area, there is a two networks like this. Okay. Now I want to make a communication between this network to this network. So what I have done, I added a device called a router, which is nothing but a inter-networking device. Router is a inter-networking device. Router is a inter-networking device. So I connected these two networks together. So this is one network. There is another network. Okay, like this. So I try to connect these networks together Okay, now it is inter-network. Now it is inter-network. What is inter-networking? What is inter-networking? Communication between different networks. For example, this C1 want to communicate it to A2. How they will communicate? C1 to this such. So A2 is not in my network, right? It is outside of my network. So I have to go through the router, reaches here, then it will go to this. Okay, this is called a inter-networking. Okay,
Yes, sir.
network, because it's a very basic definition, guys. Okay, what is a network? Interconnection of two or more devices is a network. Communication between these interconnected devices is called a networking. What is internetwork? So we have a different network, separate different networks are there. If you are able to connect, you're connecting those networks, that is called a internetwork. You are making communication between these different networks, means devices in these different networks can able to communicate each other, right? So you are communicating means internetworking. Okay, so guys, what is meant by communication? What is meant by communication? In the network, guys, different communications are there. Either you are sending a messages, or maybe you will send a mail, you are maybe send a message, or maybe you share a resources, maybe you share a data. Sharing resources means I have a printer, I share a printer through network, that is sharing resources. I have a data storage space is there, I can store data in the that storage which is not connected to my system, it is connected in the network. I can store data in that one. I can able to access web pages. Now we are accessing websites. That is also communication. Mail communication, web communication, chat communication means instant messaging communications, resource accesses, database access, right? These are all comes under communication only. Okay. For connecting devices first, you use hub or a switch kind of devices for any LAN connectivity. Okay. For network purpose. Simple network. Exactly. It's a LAN or local network it is. Your network, your segment. We create one single segment. Router,
Sir,
I use another device is router. Yeah, tell me.
is this called gateway?
Yeah, very good. Very good. The gateway is here. I will point here. So, for example, this C1 want to communicate it to A2. A2 is not in this network, right? So the packet has to go from like this to go outside of my network. It has to go like this. A1 to B1. So packet go to switch or a hub and reaches B1. But C1 to A2, packet has to go outside of the network. Means this is this is my gateway. This is the gateway. Same as for this side. If B2 want to communicate it to B1, so B1 is not here, right? So B1 has to send a packet to the router, means outside of the network. Then only it can reach outside devices. That is our default gateway. Okay. The gateway is a simple concept, guys. It is either gateway is a device or an IP address, or maybe it can be just a concept. Like this is the way you can able to go outside of your network. Okay, to communicate outside of network devices, you should go outside, right? Outside of your network. Which way is you have to go, that will be told by default gateway. Router is a inter-networking device. Inter-networking device. It means it make a communication between different networks. Make communication between different networks. Just to know why I use a hub or a switch for creating a one segment or one network. But you want to make a communication between different networks, we need a router. Of course, there is a lot of devices. Anyway, we will going to discuss that one later. Guys, in networks, we have a logical topology and physical topology. Logical topology and physical topology. So, first of all, network means connection, means physical connectivity. Networking means communication. Networking means communication. It's very simple. Connection is there, network. And connection is there. Now we want to make them communicate. Okay. Now it is communicating, means there is a networking. Okay. Networking. Network means connection. Network means communication. For networking, of course, we need a network. Without network, there is no networking, right? And network, and we need a logical addressing, which means IP address and protocols. We need a logical addressing and protocols to communicate. In network, we need a connection. So how you will connect? So connecting devices required, like hub switches, routers, NICs, devices like a hub or a switch or a router, like that. So devices required, NICs, maybe cables. If it is a Wi-Fi, we can connect with a different kind of stuff. So network and networking. These physical topologies. Guys, understand network and networking?
Yes, sir.
Sir, what is NIC?
Network interface card. Network interface card. I will tell separately what is NIC, how NICs look like, and how we connect both wired and wireless NICs. That I will tell. But yeah, I will continue. Physical topologies. Physical topologies is nothing but the way the devices, like your systems, computers, laptop, whatever it is, the way the devices are connected. Okay, how they are connected. How their devices are connected. It means it's a to form a network in the way you will connect devices. So that is a network. So logical topologies, also logical topology, logical networks are based on logical address. Logical address configuration. So then logical addressing is there. It means to communicate in the network, we need a logical topologies and logical addressing and protocols. So logical topologies will be created based on logical addressing. What is it is? IP address, example, IP addresses. Configuration. Okay. So first one is I will try for a physical topologies. What are the physical topologies and what is their diagrams and all we'll see. In PPT it is up and down kind of stuff. A physical topology is a physical layout of systems connected in the network. Different type of topologies are bus topology. Traditional way, guys, there is a 4 topologies plus 1 in a traditional textbook topologies. One is bus topology, ring topology, mesh topology, star topology, and hybrid topology. So hybrid is also in the traditional part only. And other things are like a point-to-point topologies, point to multi-point topologies, tree topologies kind of stuff. So here in this one, first of all, I will draw one by one topologies and I will explain orally, guys. But the text you have to get it from other PPT part. Okay, but concentrate and listen carefully. So one by one point will be covered here. I have a devices. Now I want to create a network. I have a devices. Now I want to create a network, right? So A is a device, B is a device, C is a device, D is a device. So these devices are connected to a backbone cable. These devices are connected to a backbone cable. So all these devices are communicating each other through that backbone cable only. Through that backbone cable only. So A is communicating to B. So A send a packet like this. A to C, B to D, D to D. Okay, like this. Entire traffic is going through this backbone cable. Usually they use a coaxial cable for this backbone cable. Okay, in the olden days we use a cable TV network, means there is a cable office. Okay, so they will have a satellite, they receive a TV kind of stuff, they will send through home to home through the cables. So they will draw one backbone cable, main cable is there, from that one they will give connection to the houses. So that is a, this is kind of a example just for understanding. Maybe you don't see, that's very olden days, means in my childhood days. Okay, not in your childhood days. Maybe some village, not even a village, some small towns may use it till maybe they are using. Villages are changed. I have seen villages, first villages start using satellite TVs. Next is the cities. That's a reverse order. Because the big towns and cities don't have satellite dish facilities. Means that for top floors are very far. So village it's okay, no problem. Single houses easily available. So point is, guys, that's not the point. So bus topology, it is called a bus topology. Okay. So devices are connected to single backbone wire. Next one is, it is simple to configure. It is very simple to configure, but difficult to troubleshoot. Why? Because of if a wire is broken, think like this wire is broken at this place. You don't understand where it is broken happen, and the further communication also it will be stopped. Means A can able to communicate it to B, but A cannot able to communicate it to C, or B cannot able to communicate it to C or a D also, because here is a wire got broken. So further communication will stop. So one side of communication, other side of communication will no access. Okay, it's easy to configure, difficult to troubleshoot. Everything depends upon the single cable. More number of devices increases, more traffic on the cable. Now this is another topology. Do you understand the first topology, bus topology?
Yes, sir.
Yes, sir.
Yes, sir.
Now I have a devices.
Yes, sir.
Very good, very good. I have a devices instead of connecting to a single backbone wire, because if anywhere it's broken, further communication is stopping kind of stuff. So what I have done, I connect one device to another device, another device to another device. Okay, that device connected to another device, and last device is connected to our first device. Last device is connected to our first device. Okay, so it is look like a ring, means the last device is connected to the first device, means it's completely closed. Okay, so this is based on a algorithm. It works based on an algorithm. A is connected to B, B is connected to C, C is connected to D, D is connected to E, E is connected to A. For example, you want to communicate from A to D, A to D. You want to send a packet from A to D. The packet will go like this: A to B, B to C, D, C to D. So what we can it's like this. Okay, no direct. But D want to send a packet to A, D to E, E to A. So what is this called? Clockwise direction. Okay, so this topology is designed either clockwise or anti-clockwise communication. To what is the problem in this one? It is also we can easily configure, but we have to configure this algorithm. So tell A should send a packet to B, B will send a packet to C, C to D, D to E, E to A. Okay, the topology every time you have to configure in that one, machines. Okay, so we don't need depends upon a backbone cable. But there is a problem. For example, this C is down. C device is down. Further communication stop. A to B communication is there, but B to D communication is not there. But D to B communication is there. So D can able to communicate it to B, but B cannot able to communicate it to D because it's their problem is occur. Okay, little difficult to troubleshoot, but the further communication will be stopped. Or a cable is broken. For example, this cable got broken like this. So A to B communication, B to C communication, but C to D is not there. Path is broken. So this one side of path is get affected. Guys, understand this part?
Yes, sir.
Yes, sir.
Loop
Yes,
configuration. Okay. So what they done? So they try to create a double ring topology. What is double ring topology? It means put two more connections like this. Not one connection, two more connections. So what happened? One side, like the dark lines, for example, clockwise. The light lines are represent anti-clockwise. Means A want to send a packet to D directly through this line. It will send. Okay, through these lines, it directly can able to send. So it become easier now. But still there is a problem in it. Okay, if device is down, still we can able to communicate either this way or other way. We can communicate. So as I said, there is an issue. What is an issue? It is if you want to add one more device. If you are adding one more device or one more device again, so you have to configure all the system with that path because the path will be broken and it should be rearranged. Means it should be go like this, and I have to remove this one, and the path should be broken. Again, I have to reconfigure entirely. So what is the algorithm configuration? Okay, this is called a ring topology. It forms as a ring. The drawing space is also very less here. Can I put one more here or not? I will check it. Otherwise, we'll do it again. Okay. So this is connecting like this. Anybody will guess what topology it is?
so star.
Star.
Now it is a mesh topology. It's not
Mesh.
star topology, guys. Okay, it is called a mesh topology. Okay, So in mesh topology, every device is connected to all other devices. What it is? Every device is connected to all other devices. A is connected to B and C and D and E also. Same E is connected to A, B, C, D also. For writing easy purpose, they write like this. Okay, it's not a star topology, it is a mesh topology. So, not a mistake at all. Why? Because when you see a star mark, so obviously mine comes with a star only. Okay, so it is not a star topology, it is a mesh topology. So, it is a complex. Why complex? You need a huge hardware part, means every device required multiple NICs to connect, and we have required lot of cables to connect. Every device has to connect all other devices, means more number of devices are there, more complexity. Okay, more complexity. Every device is connected to all other devices. Okay, next one is, it is a redundant type. It means if one of the devices is down, no problem, other devices will communicate each other, right? One of the devices down, no problem, other devices will communicate each other. For example, this wire is broken, means A to B communication is stopped, but remaining communication going on, A to E, A to D, A to C communication is there, B to A, sorry, E to A, E to B, E to D, E to C communication is going on. So it is completely independent. The device is down, that only won't communicate. Okay. Or wire is broken, only the end-to-end devices, that points to point devices will won't communicate. Remaining communication is going on. Okay. It is a complex but more redundant. But there is one more point, it is difficult to troubleshoot. Difficult to troubleshoot means you don't know where issues occur. Where issues occur. So which cable, where is the cable? Lot of cabling is there, lot of connections are there. So that is one risk part. And one more is difficult to scale. Difficult to scale. Difficult to scale. Difficult to scale means I cannot add more devices. If I add more devices, more cabling, more connectivity. Okay, so that is the problem with this mesh topologies. But still, this mesh topologies using bus and ring topologies we are not using now, but ring topology kind of stuff we are using. Okay, but sorry, bus topology, ring topologies we are not using now, but mesh topology we are using, but not in a regular networks, guys. Mesh topology used in a special cases like a SAN topologies, SAN storage area networks. Mesh topology is used for redundancy purpose. Servers side core servering, so core routers for redundancy purpose. They may use a mesh topologies, not in a regular networks. Okay. So three topologies I told. One is bus topology, another is ring topology, mesh topology. That's my mistake. Next one is we'll go to the star topology and extended star, and remaining also will tell. Very good. Okay. So we want like these devices, arrange it. So this is a centralized device. The devices, okay, means I have a APC, BPC like this, D, E, F. Okay, devices are connected to the centralized device. Okay, what is the thing? It is very easy to configure. Comparatively other topologies, we need an additional device, not only cable connectivity, but also we need an additional device, centralized device is required, which is either hub we can use it or a switch we can use it. So we are all communicating through this hub and switch. So A is not communicating to B directly. It has to send a packet through hub and hub to B. Okay. So all communications going through this hub or a switch. Okay. It is simple to configure, easy to troubleshoot, and it is scalable. Okay, easy to troubleshoot, it is scalable, but not redundant like a your. But 2 points, 3 points are there, guys. I will tell one more. If C device is down, remaining devices will communicate each other. C is down, that's it. Or this wire is broken. So only F device is not communicating. Remaining devices will communicate each other. Okay. What if this switch is down? Anyone?
No device will communicate anyway.
Very good. So no device will communicate. So entire communication is done. So how it is, so that's it is not redundant, but how it is very good. Why we are using this topology? It is called star topology, guys. And currently we are all using star topology only. Star is a in our regular networks, in our regular network, we are all using star topology only. And why? Because of it is very easy to configure. You don't require a lot of cabling kind of stuff. Just we need a centralized device and connect your devices to this central device like a hub or switch. So we'll get a network connected. And it is easy to troubleshoot because hub and switches having LED indicators, connectivity status it is shows. So we can easily identify where is an issue. So then we can able to resolve an issue faster. And it is scalable, means in your organization you have a multiple devices, lot of computers are 50 computers, 100 computers are there, but these switches or hubs having a limited port numbers. Okay. So but still we can able to think. So hub is, for example, you take a hub or a switch, take switch. So for bigger networks, switch is better. For small networks, okay, like this. Okay. So this is another network, it is another segment. The same billing, I have another network, and some devices I connected to this hub or switch. Now I have a multiple devices, so then those are all connected like this. Now these devices has to be communicate, right? These devices has to be communicate. How to make it communicate? So there are two different networks. Means two different, not two different networks. It is two networks, two segments. How to make a communication between them? Very simple. Connect from here to here. Just I am using a dotted line, which is in this case, this dotted line representation of crossover cable. Okay. Naming is for our convenience. Okay. So this is called a extended star topology. Means it's a star topology, but topology got extended. Star topology got extended. This is called a extended. Means single star become bigger star now. Multiple devices are there. Means number of devices are high. Still we can make them connected each other. We can make communicate each other. Okay, as a single network. As a single network. Not as a multiple networks, as a single network, we can communicate each other. As a single segment, we can communicate each other. So this is the star topology. Easy to configure, easy to troubleshoot, and easy to scalable. Guys, understand what is star topology?
Yes, sir.
Yes, sir.
Okay, so you have a device like a device A to B. If you are able to connect, just you are connecting. See, this hub to devices are connected, or switch to devices are connected. In a ring topology, one device is connected to another device. In mesh topology, one device is connected to another device. These are all comes under point to point. So that is also called as point to point. One device is connected to another device straight away, that is point to point. But usually this point to point concept between the routers in WAN protocols. I have a router 1 and router 2 is connected in a point to point. Okay. Usually in a WAN links, we use this word called a point to point, serial point connectivity. Point to point means a device is connected to another device, that's it. Okay. And last one is point to multi-point. Means this is, I have a head office, for example, and I have a multiple branch offices are there in different areas. One is in Hyderabad, one is in New Jersey, one is in London, for example. Okay, I have a different branch offices are in my for my organization. So I want to connect, so then they can able to access my infrastructure, my servers, right? So I'm connecting like this. So this is my main office and it is connected to other organizations. So what is this? This is one point to multiple point. Point to multi-point. Main office is connected to multiple places. point to multi point. Okay, so these are the topologies. It's become very bigger and reduce it, this one also reduce. Why it is not going up? Okay, these are the topologies. One more topology I will give you, that is called a tree topology. The tree topology concept is very simple. It is gone. Oh. This tree topology concept it's a kind of hybrid topology only. If you see, there is a backbone cable and it is connected to different other topologies. Okay, connecting directly to a servers or connected to a switch, and it is connected to another systems like that. That is, it's created a tree topology kind of, just like look like a tree type. Means there is a trunk and there is having a different branches kind of stuff. Yes, this is a tree topology. So these are your physical topologies. Okay, up to here.
Okay, sir.
Yes, sir.
So tomorrow we will discuss from one by one what is LAN, what is CAN. Otherwise I can tell now also. Yeah, that is enough for today. Okay. So tomorrow we'll start a LAN, MAN, CAN and devices and ICs and all. Okay. Already have some PPT, then also go with that one. First read about, complete this service desk related things, guys, everything service desk related first. Then go tomorrow morning, you can study networking basics. Today, complete this service desk part. Okay. Yesterday, today, what are we discussed and what are the links I shared? Try it. Okay. That's it for today. Meet you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.